Hello everyone, today let's solve find first and last position of element in sorted array. So given an array of integer nums sorted in ascending order, we have to find the starting and ending position of a given target value. So let's use this array as an example. Target is 5, right? So the start position of the target 5 is 2, right? And the end position is 9. So to solve this problem, we can leverage binary search. Since the array is sorted, we have to use twice. The first time is to find the start position, and the second time is to find the end position. And for the binary search, the condition I will use is this: L plus 1, left plus 1 smaller has to smaller than the right. Okay. And let's find the first position together. And the logic is this: so as long as the middle value is the same as our target, we have to move our right to the left. Okay. Else is the same as the binary search, right? If the target is bigger than our middle value, we just move the left, right, to the right in order to find a bigger one, right? Else we just move right to the left in order to find a smaller one. So let's see. So in this case, middle value is 5, right? So we just move right to the left, okay? In the second round, m is here, and the value is 5, is still the same, so we just keep moving our right index, right pointer, okay? And the third time is smaller, right? It's smaller than our target, so we have to move our left to the left, to the right. Move our left to the right. So in this situation, right, we no longer satisfy this condition. So we just compare. First, we check the left part because left index is always smaller. Okay, the left index is always smaller. So we check whether or not left is our target, right? If it is, if it is not, then we check right, okay? And in this case, right is our target, so we just return 2. Okay. So let's find the end position together again. And this time, the only difference is this: as long as our middle value is the same as our target, we have to move left. Okay, we have to move left to right in order to find out the ending position. Okay. Else, okay, it's the same as binary search, right? Target is bigger than our middle value. We just move left to right in order to find our bigger value. And if the target is smaller than our middle value, it means that our middle value is too big. So we just move right to the left in order to find a smaller one, right? So let's see. Our middle value is 5. It's the same. So we just move left to right, okay? And the second round, our middle value is 5. It's the same. So we keep moving left to right, okay? And third round, it's the same, right? So keep moving. Fourth round, 5 is the same. So keep moving, right? And in this situation, right, we no longer satisfy this condition. Left plus 1 has to smaller than right. So we just check right first. This time we have to check right first because right pointer is bigger, right? Because we will have to find ending position. Maybe after we break the condition, both index points to 5, okay? But we have to return the end position. So we have to check the right first in this case. So check right first. If it is not the same as our target, then we check left. Okay, and in this case, left is our target, so we just return 9. So let's code together in order to have a better understanding. Okay. Oh, by the way, the time complexity for this algorithm is log n because we use twice binary search. and we don't use extra space, so the space complexity is O1. Okay, so let me create two functions. First one is to find first, okay, and the second one is to find last. Input slice of int, our target, right? Int, and the position int, and the same as our find first function. So for our main function, we have to check the boundary. So if our nums is nil, or the length of our nums is equal to 0, we just return minus 1, means nothing. We cannot find anything. Else, we just return what we found. So find first, and then find last. Nums target. Okay, so let's implement the find first. Okay, so binary search, right? Left and right. Left start from 0, right start from the end index, and position, which is not length of the nums minus 1. So condition here, as long as left plus 1 is smaller than right, we have to check. Right? We have to find the middle index first. Left plus right minus left divided by 2. Okay. So condition here. So if nums, if our middle value is the same as our target, we have to move our right index to left in order to find a smaller position, okay, smaller index. Else is the same as binary search, right? So if our target is, our middle value is smaller than our target, we have to move left to right in order to find out a bigger one. Else means that our middle value is too big, so we move our right to left in order to find a smaller value. And if we break this for loop, means that we no longer satisfy the condition, right? Like this. So we have to find the left. We have to check the left first. So check whether or not left is our target. Because in this situation, maybe both left and right index are pointing to 5. But we have to return a smaller one because it's start position. So we have to check the left first. So return left. Else nums right equal to target, we return right. And else we return minus 1. Means both index points to different value, minus 1. And it's almost the same as find, in order to implement find last, it's almost the same as find first. Just change the condition here. We have to change this first. Instead of moving right to the left, we have to move left to the right. Okay. And here, instead of check left first, we have to check right first. Because in this case, maybe both left and right index points to 5. Both points to 5. But we have to return the last index, right? So we have to check the right first and then check the left. And if both are not satisfied, we just return minus 1. Okay, and that's it. So let's submit it. Okay, sorry. So I forgot to else if here. Else if submit. Okay, we pass. So that's how we solve this question. Thank you for watching.